Could an undiscovered planet be hiding in the farthest reaches of our solar system? Increasingly, astronomers are convinced that the mysterious Planet 9 is not just a myth but a reality. This belief isn't based on mere speculation, it stems from compelling evidence. Unusual anomalies in the orbits of objects within the Kuiper Belt strongly suggest the presence of a massive, unseen celestial body. Adding to the intrigue, a team of researchers is confident that an unknown planet exists on the solar system's outermost frontier. But what exactly supports this groundbreaking hypothesis? Why hasn't Planet 9 been officially identified yet? And what makes this search so extraordinarily challenging? The story of this elusive planet is closely tied to fundamental questions about the origins of comets. Have you ever wondered where these icy wanderers come from? Dutch astronomer Jan Hendrik Oort pondered the same question. Unsatisfied with vague explanations, Oort proposed in 1950 the existence of a vast, spherical region at the solar system's edge, which he called the Oort Cloud. This region, he argued, could serve as a reservoir for long-period comets. However, his theory left the origins of short-period comets unexplained. Enter Gerard Kuiper, who, in 1951, hypothesized the existence of a belt-like structure beyond Neptune's orbit. Today, this structure, the Kuiper Belt, is an established concept in astronomy, though its existence wasn't confirmed until 40 years later. The Kuiper Belt is a ring of icy debris just beyond the orbits of Neptune and Pluto. It contains not only comets but also remnants from the early solar system. Yet, it may also hold clues to a much larger mystery: the presence of an unseen planet that could transform our understanding of the outer solar system. This belt of small, icy objects has long fascinated astronomers. However, beyond its dwarf planets and debris lies an even more tantalizing possibility. The Kuiper Belt might be concealing a massive, undiscovered planet, a giant world that has so far eluded even the most advanced observational tools. What evidence supports this compelling idea? And how likely is it that humanity has overlooked such a significant planetary presence for so long? Surprisingly, the notion isn't as implausible as it might seem. If this hidden planet exists, it would lie far beyond the orbits of Neptune and Pluto, in a region so remote that it remains almost invisible to even the most powerful telescopes. Fortunately, astronomers aren't relying solely on direct observation to uncover this mystery. By studying the gravitational effects Planet 9 might have on nearby objects, scientists hope to shed light on its existence and location. The search continues, and with it, the possibility of rewriting what we know about our cosmic neighborhood. One expert uniquely attuned to the mysteries of the Kuiper Belt is Michael Brown, an American astronomer who has dedicated years to studying the icy outskirts of our solar system. Among his most notable discoveries is the dwarf planet Eris, a finding so impactful that it played a key role in the 2006 reclassification of Pluto, stripping it of its planetary status. While Pluto's demotion remains a topic of debate, Brown looks back on his involvement with a mix of humor and pride, even dubbing himself the Pluto Killer on social media. Yet, his work in the Kuiper Belt extends far beyond Pluto, leading to groundbreaking revelations about our solar system. In 2006, the same year Pluto was reclassified, Brown and his team identified a group of celestial objects known as distant detached objects. These discoveries formed the basis of a revolutionary study suggesting a tantalizing possibility: an entirely unknown planet could be lurking in the outer reaches of the Kuiper Belt. Collaborating with his colleague Konstantin Batygin, Brown began piecing together evidence for this enigmatic world, potentially the long-hypothesized Planet 9. If confirmed, this discovery could reshape our understanding of the solar system's farthest regions. Batygin focused on the puzzling behavior of certain Kuiper Belt objects, whose orbits defied explanation. Follow-up research uncovered an extraordinary pattern. 6 of these objects followed elliptical orbits that all pointed in the same direction, despite their differing sizes and speeds. Even more intriguingly, their orbits were tilted by approximately 30 degrees relative to the plane in which most planets and objects in the solar system reside. Could this alignment be a coincidence? Brown was convinced it wasn't, calculating the odds of such an occurrence to be just 0.7%. Dismissing the idea of mere chance, The team initially considered whether the gravitational pull of multiple massive objects, like a cluster of dwarf planets, could explain the anomalies. However, this theory was quickly discarded, as it would require the Kuiper Belt to be 100 times more massive than it is. Seeking a more plausible explanation, Brown and Battigan turned to advanced simulations. Their groundbreaking conclusion: the observed anomalies could be caused by the presence of a Neptune-sized planet. This hypothetical planet 9 would have an unusual orbit, tilted dramatically and positioned 180 degrees opposite the orbits of other planets and Kuiper Belt objects. Further observations, including the peculiar trajectories of trans-Neptunian objects like Sedna, lent additional support to this theory. But if Planet 9 exists, why has it eluded detection? According to models, this mysterious planet is estimated to have a mass between 9 and 10 Earth masses and orbits the Sun at an astonishing distance of 400 to 1,500 astronomical units (AU). For perspective, 1 AU represents the distance between Earth and the Sun, about 150 million kilometers. While Earth completes its orbit in just 365 days, Planet 9 would require an incredible 20,000 years to complete a single revolution around the Sun. This staggering distance, coupled with its likely dim appearance, has made Planet 9 incredibly difficult to observe. Yet, the search continues, driven by the potential to uncover one of the most significant discoveries in modern astronomy. The vast distance separating Planet 9 from the Sun places it far beyond the capabilities of most conventional telescopes. Adding to the challenge is its faint luminosity. Model calculations from the University of Bern indicate that Planet 9's intrinsic brightness is just 0.06 that of Neptune, which itself is relatively dim at 0.01. Furthermore, Planet 9 is thought to emit most of its radiation in the infrared spectrum, with an estimated surface temperature of 47 Kelvin, -226 degrees Celsius, only slightly warmer than the cosmic microwave background. Does this mean Planet 9 will remain forever undetected? Not necessarily. If the planet is currently near its closest approach to the Sun, it may already exist, albeit unrecognized, in archival sky survey data. Additionally, advancements in telescope technology and observational techniques offer hope that this elusive celestial object may one day be identified, potentially solving one of astronomy's most intriguing puzzles. Despite the uncertainties, there is reason for optimism. The discovery of Planet 9 could become a reality with the help of cutting-edge instruments like the Vera Rubin Observatory. However, patience is necessary, as this powerful telescope is still under construction and is not expected to be operational until at least March 2025. Uncovering Planet 9 would not only expand the list of known planets in our solar system but also raise profound questions about cosmic formation. Its existence challenges conventional models of planet formation, which suggest that giant planets form in regions rich in gas and dust, close enough to the Sun for ample material to coalesce. Planet 9, by contrast, resides at an average distance of 700 astronomical units from the Sun, far beyond the region where planet formation is thought to occur. This raises a fundamental question: how could a planet just slightly smaller than Neptune form in such a remote and eccentric orbit? This conundrum stretches our current understanding of planet formation to its limits. Simulations suggest that Planet 9's structure is similar to Neptune's, with an icy outer layer and a dense atmosphere of helium and hydrogen. However, forming such layers would require prolonged exposure to the gas-rich central regions of the primordial cloud, a condition Planet 9 likely never experienced. If Planet 9 exists, researchers propose three main theories to explain its origins. 1. Formation in place with orbital disruption. One theory suggests that Planet 9 formed in its current location within a stable, circular orbit. Its eccentric trajectory may have been caused by a gravitational encounter with a nearby star, which disrupted its orbit. However, this scenario requires the Sun's original gas cloud to have been far larger and longer lasting than currently assumed. It also raises the question of why Planet 9 wasn't completely ejected from the solar system during such an encounter. 2. A captured or stolen planet, Another possibility is that Planet 9 formed in another solar system and was later captured by the Sun's gravity during the early days of the solar system, when the Sun was part of a stellar cluster. However, the likelihood of such an event occurring is extremely low, estimated at just 1%. 3. Ejected but retained. The most plausible theory posits that Planet 9 initially formed in the inner regions of the primordial cloud, alongside Jupiter, Saturn, Uranus, and Neptune. Gravitational interactions and turbulence in the young solar system may have pushed it outward, eventually settling into its current distant, eccentric orbit. While most planets ejected this far would typically be lost to interstellar space, Planet May 9 have been slowed by dense gas in the primordial cloud or the gravitational pull of a nearby passing star, preventing its complete expulsion. Interestingly, the discovery of an exoplanet in a binary star system with a similarly extreme orbit provides some support for this third theory. Still, despite these plausible explanations, Planet 9 remains a hypothetical entity, a missing piece in a cosmic puzzle. Perhaps future advancements, such as observations from the James Webb Space Telescope or the Vera Rubin Observatory, will finally illuminate this enigmatic object. Until then, the search for Planet 9 continues, inspiring curiosity and driving us to expand our understanding of the solar system's farthest reaches.